Uh, Hello, participants. Welcome to the 60-minute bootcamp session on data science. We are delighted to be collaborating once again with MCET for this event. And our team was genuinely excited about the opportunity to interact with all of you during the session. Let's dive deep into the session and explore the depths of data science. Additionally, I would like to express my thanks to Uma ma'am for organizing this bootcamp and making it possible. Thank you very much for your efforts, ma'am. Thanks a lot. Over to you, Pooja.
Pooja, I think you're on mute. Oh, thanks a lot, Sandhya. Uh, that was one of the reasons that I believe I've been speaking. So, okay, thank you. So, to take this session forward today, I would like to first discuss with you today that we are talking about a predictive analysis session. So, in this predictive analysis session today, we have a solution on breast cancer prediction. And even before I take you ahead in this session for breast cancer prediction, my you know I am looking forward to your insights as to, do you think that I could build up a model that can 100% say that breast cancer could be predicted with a 100%? There's a humble request, students, that you'll have to keep yourself on mute, and only then I'll be able to go through this session in a more you know well performing manner. So please keep yourself mute as you're joining through this session here, and we'll be actually having a really exciting solution to look forward to. Okay, so let's get started. So I was talking to you that how many of you think I can, if I get a artificial intelligence solution for prediction, I can get close to 100% accuracy. A yes or no in the chat would be really helpful. You could put across your views as to, do you think if I design a model, if we work on an artificial intelligence solution, that solution can take us to a prediction where I'm able to say that, oh, with 100% accuracy, my model is able to state that cancer is malignant or benign. So I'll talk about these terms called malignant and benign, but it'll be good if we have an interactive session together today going forward. Okay. So getting back to our discussion, we want to talk about and tackle about an interesting problem where we say that a lot of humans throughout the world are affected from breast cancer. And we want to tackle this problem with artificial intelligence. We would require a lot of big amount of data that will help us perform this analysis. And hence we say that data is the prime key for enabling us to find a solution for this issue. And then we will also do a simple code snippet exercise once we go through this discussion on the problem. And after that, we will get into building of our solution source for today, which is our breast cancer prediction engine. So this is the way this is the agenda that we'll follow going forward for this 60-minute session. So you all should be geared up. You should be onto your laptops. That way you will be able to set the kit also with us onto your systems. So let's get back. And you will see that in the chat, there would be a link shared by one of my colleagues. So just click on the link. Yeah, just click on this link that is being shared. Okay. And this link will take you to this page, which is specially designed for you guys. Okay. This page is specially designed for you guys where, you could check out what are the learning objectives from today's session. You will know a bit on the fundamentals, and then you can also follow a 3-step process where you can actually check out this uh, this solution, or let me say that this is a 10-minute solution where you can revisit the concepts that we discuss in the 60-minute boot camp through this video that you are seeing in the screen. And here we have our Candy one-click kit. So as MCT, he has already attended sessions with that, but still I would like to give you a little brief on what a Candy one-click kit is. So as you click on this link, it basically takes you to a kit page. This kit page has instructions on how you can set up the kit manually. But if you follow alongside with me, you can set it up simply as of now onto your systems if you're on a Windows system. For Linux as well as Macintosh, the instructions are listed down here. So yeah, I was talking about that this space that is specifically designed for this session, you can go ahead, click on this one-click kit and set things onto your systems. We've also mentioned the snippet exercise here for you to come back and check later how you can, check out Candy to use it to search for code snippets. And then there is a third step that will help you take an assessment with us. All right. So getting back to our Candy one-click kit, what this kit is and how you will be able to build a solution with this today. So basically, it's a one-click solution where you download it from this kit page that is available. It is in the form of a installer, kit installer zipped file. So you go ahead and say show in folder. And here in show in folder, you just have to right click and say extract all. Please follow this process very diligently so that you are able to set the kit smoothly onto your systems. Right click and say extract all. Once you have the extracted folder, double click the folder, go ahead and you will find a batch file. Double click this batch file. You just say more info, run anyway. So basically, this is an executable file that is getting set up onto your systems. And this file has all the requirement dependencies for you to set up. So the good thing is everything will get set up onto your systems automatically. You don't have to, start from scratch. Think about, I want sklearn, I want a particular library downloaded, and then you're using it into your code. So everything will get set up automatically for you. Let this process happen. Okay. And in the meanwhile, whatever it is asking for you, if it is asking you to set up a Python, if it is asking you for a VS Visual Tools, let this setup happen. You can minimize the screen and follow through the session for the concepts that are used in the kit today. So I just want to understand that you're able to set this kit onto your systems. If there is any doubt, you can put that doubt across in the chat. You can use the raise hand feature and say that you're able to set this kit onto your systems. Were you able to follow through the process? Is there any confusion? Would you like me to repeat? You can put that in the chat if you would like. It'll be good if you interact. That will be beneficial for you guys itself. All right. We get back to our session discussion. So, talking about breast cancer statistics, we see that this issue of breast cancer is pretty much common in women, but it's not just a specific region of women which are affected. If you see, it is spread out throughout the world. And specifically, you see that a lot of people in Western Europe, in New Zealand, as well as America and Asia are affected through it. In fact, the last data that has been put by the International Agency for Research on Cancer and World Health Organization on the website have mentioned that most of all, you would see that 2 million new cases are recorded as of the 2020 year. And post that, 1 in 8 women in US are also diagnosed with breast cancer in her lifetime. So this is not something which is a very generic, I mean, very specific issue, but a generic one, and does affect a lot of people around the world. Every 46 seconds also, there's someone in the world who's dying from this cancer. Okay. So in fact, it not only affects women, it also affects men. And you could also see the stats that nearly more than 1,800 men and women per day are getting affected by it. So in the year 2020, more than 7 million people in the world were living with this breast cancer as a problem. So what we would want to do is we want to use machine learning to tackle it. And even when we talk about machine learning, it is basically a method where you ask the machine to, you train the machine to behave and make decisions like us as humans. So either you would select a supervised mechanism or an unsupervised mechanism. So first of all, a supervised mechanism is very much similar to how we interact as let's say I am, if I am a baby and I'm a newborn baby, then slowly, it'll be my parents who are going to guide me into doing things. They're going to help me recognize objects. Okay. They'll say that, this is an apple. They'll help me know that this is a cat. They'll be the ones who will supervise me. They'll be the one who will teach me. They will actually give me, props of things so that I learn from them and then I'm able to recognize them in the real world. So similarly, when we say and talk about a supervised mode of learning for our machine, we provide the expected output. Okay. And when we provide the target value, your expected output, then that type of learning is a supervised learning. And today we are going to talk about within the supervised learning also the classification form of supervised learning. So in the class, there are two categories. Either you will say classification or you say regression. We want to focus on classification. So classification problems are where today, if I see, I have either I would say a person is having cancer or person is not having cancer. So either the tumor that is being detected, it is malignant or it is benign. So when I say it is malignant, then I am saying that it is cancerous. And when I say it's benign, then I'm saying it is non-cancerous. So these are medical terms. But we are more concerned with these two categories, either to state a cancer as, uh, you know, going to be malignant or as benign. So we have two categories, two binary classification categories that we want to train our machine into. Just simple mechanism we are following here. This is the simplest mechanism where I would put my machine through a lot of data. I'll train my machine on a lot of data, and then through that data, I would want my machine enabled enough that when I test it against a particular set of data, then it will be able to determine whether the particular cancer tumor is malignant or benign. And there are different mechanisms that we can use for binary classification. We are intending to use support vector machines. So I'll tell you what these support vector machines are. Before we go ahead and discuss this algorithm, I quickly want to ask, what are the other supervised learning algorithms that you may have heard of? Have you heard of any algorithms or have you not heard of any algorithms? Anyone? Have you heard of logistic regression? Have you heard of decision
Some
trees?
classification.
Yeah, yeah. Any classification? Go ahead.
Mm. Ma'am, K-means clustering. This comes
Yes.
under unsupervised learning, right?
So, see, one important thing is, Unnameshwari, if I'm not pronouncing your name wrong,
Yeah,
we
yes, ma'am.
are, yeah, we are more concerned with a mechanism which is under supervised learning. You could go
Okay.
for both. Yeah, currently, the reason is I'm saying that I'm
Yes,
going to provide the expected output. And in
yes,
k-means clustering, we are
yes,
just trying to segregate similar data points into different
yes, yes,
clusters.
yes, yes, yes.
So good attempt, but my suggestion would be any other algorithm you remember which you could
Mm.
suggest. So, I mentioned decision trees. Uh, that's
Yes,
one.
ma'am. Yes, ma'am. Decision trees. Yes,
Correct, correct, correct. So, so,
yes.
so, couple of you could have this question that, you're talking about support vector machines. So I'm just trying to plant some questions into your mind. That way, this session will be more interesting and learning experience for you guys. Okay. So my only suggestion is I'm saying I've chosen support vector machines, but why? Why should I chosen support vector machines? So I'm going to talk about support vector machines right away. That even in support vector machines, there are different categories. I'm using the linear SVM classification. What is a linear SVM classification? So basically, when we say or we talk about this interesting algorithm here, what I'm trying to do is I'm trying to separate my points. At the end of the day, all the data that I'm feeding into my machine is in the form of points, okay, data points. And what I'm trying to do, I need two types of points. Either my data should reflect that, based on certain features, whether that person is having cancer or that person is not having cancer. So what I want to do, I want to differentiate or increase the distance between that kind of discrimination or classes. So I say that either I will split my data into two sorts of classes. One will be, let's say, a class called cancerous, and another is a class which is non-cancerous. Okay. And in these two classes, how do I do this differentiation? How do I increase the distance of the data points? How do I make it more clear for my machine to make decision? Okay. So what I am doing, I'm trying to create a best decision line or a best decision boundary between the data points. And how am I drawing it? I am actually trying to create a maximum margin line with respect to the positive as well as a negative hyperplane. If you see in this figure here, if you see, this is your positive hyperplane, this is your negative hyperplane. But do you think when we supply the features to the machine, are they already separated? No. Suppose there is a certain texture, mean radius, mean diameter. These are the features, okay, in the human body. And these different features are what, alongside with the expected output is being provided to the machine. Then based on certain features, we would say that if these features map, then you put it into a cancerous category. If these features, particular feature of this point is matching, then you put it into a non-cancerous category. So this maximum distance, how do you find a line which is at a maximum distance? Can't it be perpendicular to this x1 axis? I could have also drawn a line which could have been perpendicular to this x1 axis. But why would I go for this slanting line? Do you think any one of you could also put some insight, or do you think like, is this a thought that came to your mind? Why have I drawn this sort of a line and why not a perpendicular line to this x1 axis for differentiating these points? So our intention is maximum distance. Okay. We want to put these into two different planes, a positive and a negative one, because we are talking about binary classification. We have just two classes, either cancerous or either non-cancerous. So the intention is we find a maximum boundary or a decision fit boundary such that the distance is maximum. So if I draw a line perpendicular, then it will be closer to these points. Or if I draw a line perpendicular like this here, then it will be closer to these points. but this line will be at a maximum distance from 2 points that we have selected as support vectors. So why this algorithm is called support vector machine, where to be able to draw this best fit decision boundary line, whatever points will lie above this line, all of those will be signifying that a person has cancer. All the points that are lying below this line will be signifying that a person does not have cancer. So we want a maximum margin line from both these support vectors. Support vectors are the corner points lying. If I try to draw a superficial artificial line around these points, this one comes at one of the corners. I have chosen this as one of the corner of this class, and I have chosen this point. We could have also chosen, but this is more at the outer end. So this as a outer point of this class, and we have drawn a negative hyperplane and a positive hyperplane. And from these two, we could see that this comes as a maximum margin hyperplane. So this line is drawn in the between. If you try to make a maximum margin hyperplane perpendicular to the x1, then that won't be possible. And what we are intending to fight, we want to fight the best fit line. So if you go through a research paper on breast cancer prediction, and you would see that support vector machines is the algorithm specifically that has provided the highest amount of accuracy. And that is the reason that we are drawn into discussing this problem statement today. So coming to the implementation part, how would you implement it? So we will use the famous scikit-learn, sklearn library here, a framework here, and from that we will actually import our algorithm and try to make the required predictions. So how do you develop quickly? If I am a student, if I am a interested developer or an enthusiast, how do I develop quickly? Use open source libraries because these are available to anyone and everyone. They help you innovate. You are able to distribute to the developer community. It's very much an open space for development where you do something, you contribute and give it to everyone, and anyone else can work on to the solution that you have provided. So similarly, every candy kit that you see today, that you can simply use, download onto your systems, customize as per your requirement. So all this is available to you. Also, we provide support, security, quality, and license, which are the 4 key parameters when you're working around a repository. So you can check all these onto Candy, onto the platform that I'll show you in some time. But let's now quickly move to our breast cancer prediction with Candy. So for that, I'll get back to my kit. Your kit should have reached here by now. Okay. It should have followed all these steps. It would say that you have your kit set up at C Candy Kate's breast cancer prediction. And then you would just say yes and press enter. This will automatically open this Jupyter notebook onto your systems. This should happen for all of you. Okay. And then I'll just run all my cells for this solution to run and showcase you what is happening in this solution here. So first of all, we have done imports for essential libraries. I said that we will do some, we will import data sets from sklearn, and we will do the model selection. So here we are using the train test split. So as I'm talking about the train test split, I would like you to check out a very simple code snippet also. So for that, I will say file, new notebook. I want you to just check out how we can find simple code snippets from Candy. So if you go down and scroll on this page that is specifically dedicated to your college, you would see that we have mentioned this code snippet exercise. This is one of the exercises that is available, but there are multiple such that you can make use of. So what do I do? On this page, I click on Candy. This takes me to a search bar here, a simple search bar, right? And on this search bar, I'll write train test split. And I mentioned the language for ease, let's say Python here, and I hit enter. And as I hit enter, I would see that there are options for code snippets. I will choose my suitable option for code snippet. And then I would see that even in these various options that are available, you could pick any that is suitable. Let me choose this one. And as I copy, I would see that there is a dependent library for NumPy. If NumPy is already not installed, you click on this. First, I'll copy paste this code. Since I see there is an import for NumPy already done, I don't require to install it. I mean, I do not copy it from here. If you don't have NumPy downloaded, then you copy this, set NumPy first, and then run this code. Okay. So I'll just remove these. Okay. And then I would just simply want to run this and show you. Just say control and enter. And you would see that the shape for the last one is showcased, your test Y. So what I'm trying to showcase here from sklearn.model, even in our code, we just imported the train test split. Similarly, what we can do, I just gave a search and I tried to get some snippets here. I copy pasted a one that I felt simple. And then I basically entered the two arrays. One is a 251 cross 2 and another one is again 250 cross 1. So that way what I'm trying to do, when I apply the train test split, I have mentioned the test size. What kind of splitting of the data set should happen? So I have mentioned a row or size of 250, and in that 250 I'm keeping 130 for testing. So I think you understand that whatever data we have to split it into two parts, one for training, another for testing, correct? So most of the part we want to keep for training, right? So let me change this to just 100. Okay, test size I want to keep 100 and training size will then become 150. So now when I check, let me just say print here, print statement, and let us print all of these separately. That way we will be able to determine the different sizes of all these four. Okay, so let me just also ask you, what should be the train X size? Can any one of you just mention it in the comments if you think you already understood that we have a 250 row size and 100 is the test size that I have kept. So what should be the train X dot shape? Anyone in the comments? Quickly, you can put it in the chat if you would like. Let me show you the result. So it's simple. I just mentioned that 150 would be kept for training. So train X would be that. Then similarly, train Y is also this coordinate. So it will be also the same 150 cross 1. And we know that the test size is what we have mentioned as 100, right? 100. So that is for testing. All right. So your text as X is 100 cross 100 and 100, and this also is test Y is 100 cross 1. So what I'm trying to intending to tell you here, when we are doing the splitting, we decide what the test site should be, and usually you keep a major portion for training. And then similarly, from this sklearn, I imported our algorithm. What algorithm we are using? SVM. And then further, I also want to showcase some evaluation metrics. So for that, I have imported the matrix. Then we try to fetch our data set. So here I had imported the existing data sets in sklearn. And from that, I have loaded your breast cancer prediction. So if you click on Shift and Tab, and then you go into the details here, then you can actually check out that, sklearn datasets include utilities that can help you load datasets, including methods to load and fetch popular reference datasets. So I'm just loading the breast cancer dataset. So similarly, if I go and say tab, so there are many other datasets that are available here, okay, for testing. So this iris dataset is also famous. Diabetes dataset is also famous. Then there is there are a lot of datasets that you can go ahead and check out here. And then there is the data analysis part, the exploring. I already have my data set loaded into this variable called cancer. What I further want to do, I want to check out the features. So what are the features that are available in my data set, my columns? There is mean radius, there is mean texture parameter, there is mean factorial dimension. So these are the different columns that are present. And then I would also see what are the output columns? So output columns is obvious. Either it will be a cancer which is malignant, or either it is a cancer which is benign, or which is non-cancerous sort of a cancer. Okay. So two target values are present here. That's why we applied the binary classification on this solution today. Then I come on that same part. I know I have my data set. I have loaded my data set here. Then I checked out my data set. What are the columns? What are the, expected outcome columns? Then I do the train test split here. So when I do the train test split here, I mention your cancer.data, your cancer.target, and the test size. So very important parameter again to mention is your test size. So you would say I've usually there is a standard split of 70% for training and 30% for testing. And hence we have set it to 0.3. And random state is also that helps in identifying the split when you are breaking down the data set. Then let's say the top portion is your 70% and the bottom portion is 30%, or the split happens, let's say 30% up is kept for testing and 70% at the bottom is kept for training. So all that randomization happens with this random state number. And then you get your X test, Y test, X train, Y train. And then you want to apply your model. So the interesting part here is when I say SVM dot and press tab, I have various options. There's a linear SVR, support vector regression, but we are using what? We are using support vector classification. So SVC is what I have used. And then there are one class SVM, there is NU SVM. So there are various other algorithm options available. So I've chosen a simple SVC. And within this also, if you go and check out, there are various parameters. So this is C, there is kernel. So the C value, kernel value, these are called your hyperparameters. What are these hyperparameters? These parameters help you get to a higher accuracy. The more tuning of the hyperparameters you do, the better accuracy you're able to get. So kernel is currently linear. And as see that there are, I'll just say shift and tab. And then I would see that by default, the kernel value is set to RBF. Okay. So let me just, currently, if I see, my model is getting me an accuracy of 96.4%. Okay. And then when I change it from this linear to a kernel type of RBF, and then again, I will have to say run all, I'm able to see that my accuracy somehow gets decreased to 92%. So what decides that what value is good? You know, what decides that what kernel value is good? It depends on the data set that you have. So if you see that we have taken a toy breast cancer data set, which is a predefined data set into sklearn, and it has a linear sort of values. So that's why when we set the kernel value to linear, you can also set it to poly, and then again you run all the cells. So you see that with poly, again the accuracy gets decreased. And with linear, if you set the kernel value to linear, the value actually gets enhanced, or I would say the accuracy actually becomes huge, 96.4. So that seems like a decent accuracy that you're trying to fetch from your model. So whatever you load it into this variable called CLF, and then you fit your model on the X train and Y train. So the training happens and the kernel is set to the linear mode. What is the algorithm that you're using? You're using support vector classification. Once I have done my training, now I want to do the prediction. So again, you say the model dot predict. CLF was where I had generated my model. So then I say CLF dot predict. I applied it in my text X test, and based on the X test, whatever the remaining data that I've used to test it, I save my prediction in Y underscore pred. Now, whatever prediction I've made, now I want to evaluate my model. Okay. How do I evaluate? There are various model metrics. So accuracy is one, there is precision, there is recall, there is confusion metrics. Okay. So there are various other metrics, but then accuracy is obviously the one that is primarily used. So the accuracy score is showcased with respect to Y test and Y pred. So you see that 96% accuracy is what we have received. Precision is very close to 98% and recall is also 96. There is a very interesting metric called confusion matrix. What is this matrix? Again, this matrix is mapped based on the category of solution. So either we said that the tumor was cancerous or it was non-cancerous. So this alternate values, if you see, this 4 and 2, these are the values that are showcasing are in error. Means if this row 1 showcases that 61 have been correctly identified. Let's say when we say accuracy of the model, what we are saying, a person who has cancer was correctly predicted for cancer. A person who did not have cancer should have not been determined for cancer. So there were 6 cases where the model was not able to correctly predict 4 plus 2. Okay. What I can do, I can go ahead and tune a bit. I can just say 0.25 and rerun this entire model again. With 0.25, I want to see if there is some improvement. So no, that the accuracy somehow gets a bit reduced, the precision increased, the recall got reduced. I'll have to tinker a bit with the random state as well. So let's say I put the random state as 108 and again run the model. So then I see that there are 7 values that are in error. Can you see? Just by changing the random state also things get affected. And now I have set the test size to 20%. And you can see there are still 6 values in error. I'll put this as 110. So based on these parameters I'm showcasing you live, the accuracy is getting changed. And now you see, look at the good amount of accuracy that we have received. 97.3% accuracy. Precision is good, your recall is good, even your confusion matrix values, only 3 values or only for 3 rows, there is a chance in error. So one thing is test size, another thing is your random state, and another thing is your kernel, which is also a hyperparameter that you can tune and get as good as accuracy as possible from this model. So this is a very, very simple code that you may have seen where we did some essential imports. Then we loaded the data set here, checked out what are the columns, feature columns, and then we did the splitting. So this is the major part. The test size, the random state. Then when you choose what kind of kernel as a parameter, that also depends on the data set. Then you fit the model, you did the prediction, and this is where I'm checking what is the result that I'm getting. So this is our solution where we are able to get close to the 97.3% of accuracy with the breast cancer prediction. And the model is able to clearly state only 3 values are in error. So that's how you would see that we did a breast cancer prediction using support vector machines. And now I would quickly look forward to some questions from you guys. Do you think you would want to ask me questions? Were you able to set this kit onto your systems? Is there any setup related questions that you have or anything? Please go ahead and ask questions. Is the kit set up for all of you? Are you able to set up the kit? Yes or no would help, guys. Okay. Do you believe that you were able to learn from this session? Okay, I feel that a couple of you have set up things. That's why we have initial few questions from the participants and answers as well. Do you want me to actually check out another one more tuning? Let me just showcase a bit of change. I'll just do the random state a bit more and let's see where it goes. Can you see? just increasing it to a value of 121 resulted in a 98.2% accuracy with no values in error for this row and only two values in error for this row. So I just believe that this should could be, and recall measure is also one. So that is where we are able to get to a very good accuracy through this model. You guys should also try and work out different permutation combinations, or that's how you can enhance the accuracy of this model. Okay, and apart from that, if you go onto the page, you know the drill. You have to set up the kit from here. You can check out this interesting symbols code snippet that we demonstrated in today's session. Also, for your assessment, you have to click here, and only then you will be able to certify yourself and get yourself, certified. Right. So you have to put down your name, email address, phone number. After you've mentioned all of this, you need to mention college bootcamp here, and then you have to answer few simple questions that are listed down here. And there is an option to also get an achievement certificate. For that, you will have to tinker a little bit with the kit. Since I showcased you how even you can tune the model for better performance. If you could get a accuracy of more than 90%, then that will be seriously, that will be really good to check out. So I guess this is it that we would like to discuss from today's session. I would now want you to ask any questions if you may have. And yeah, that's there for today. I guess over to you, Sandhya, if you would
Yeah.
want to do. Okay, I guess there is a question. Go ahead, please.
Ma'am,
Yeah, please.
ma'am, you said about decision trees, no, ma'am.
Mm-hmm.
Yeah, while constructing the decision tree, we want to collect all the data. That means predictions, right? After that, only we can construct some decision tree. How the decision tree was useful in this cancer prediction, ma'am?
We haven't used the decision tree algorithm, if you have heard
Yes, you
clearly.
said about something.
I was saying support vector machines. So we used
Okay.
another
No, no,
algorithm.
I said that one. SPM, I seen that one. But starting of the class, you talked about some decision trees, no, ma'am. So
Yeah,
whether
yeah,
that
yeah.
decision trees was useful in this prediction, ma'am?
Decision trees can also be used for making the prediction. And
Oh,
the only thing is we are not able to get to accuracy as good as support vector machines.
yes, I understood now. Okay,
Yeah,
okay.
yeah. Okay,
So
perfect.
comparing to decision trees, SVM is a suitable algorithm to predict accuracy, right?
Correct, correct, correct. For this particular solution.
Yes, yes,
So
yes, yes,
that,
yes.
yeah.
Particular.
Okay.
Okay, ma'am.
Good, good,
Okay,
good. Any other questions you have now? Students, you
ma'am.
could go
Whether,
ahead and ask. Mhm.
ma'am, one more, ma'am.
Yeah.
Already some AI related projects was there to predict this cancer prediction.
Mhm.
Some algorithms was there. What is the variance according to that before released projects and this present products, ma'am? Project.
So this support. So there has been initially logistic regression also. There has been regression algorithms also they've tried. But
Okay.
ultimately we want to get to the highest accuracy of prediction. And if you
Okay.
see, we were able to get very close to 98% accuracy with the
Okay.
current solution. Hence,
Okay.
we tried to get to the current solution. Okay.
Okay, ma'am. Okay.
Okay. Thank you so much. I hope this session was helpful for you guys. And yeah, we look forward for more interesting, participation as well as queries
One
from you
more, ma'am.
guys. Okay.
Last question, ma'am.
Sure, sure, sure. Please go ahead.
Which that NumPy you used, no, ma'am?
Yeah, yeah. Okay.
Which package of Python we can use, either or Jupyter or
You can
Anaconda?
use, yeah, yeah. So Jupyter Notebook basically helps you execute the code, ma'am. If you would like to go for Anaconda, it's a heavy, heavy framework of sorts. And if you are
Okay.
able to download the kit that we showcased you, you don't have to make
Okay.
efforts to even download Python separately, download NumPy, sklearn. So
Okay.
let me show
Okay.
you one thing.
Okay.
If you see the code here,
Okay.
if you go through the code here, so even to import these libraries in my code, these need to be downloaded onto my system, correct? So all
Right.
this download is happening for you through this setup. So these
Yes.
dependencies
Okay.
are, yeah, automatically set up, and they're also into a path. And that path
Whenever
is
we register with this link you have provided, we can use all this one, right?
correct, correct, correct. Uh,
No.
yeah. And then I hope you were able to understand the setup as well. How did we set up?
Okay. Okay, ma'am.
You are able to get it? Like you just have to go
Yeah. Yeah.
ahead. Okay.
Okay. Okay, ma'am. Okay.
All right. Okay. Any other questions? Okay, Sandhya, I think we are good to go for now.
Yeah,
Over to you.
yeah, thank you, Pooja. So, students, as Pooja said, in order to receive your certificate and badge, please take the assessment and fill out the necessary details that are required and answer 5 simple MCQ questions to receive your certificate and badge. So, you will receive your certificate and badge via email within 7 business days from assessment submission. So, request you to submit your assessment by tomorrow evening. We will also send you a follow-up email with all the resources that we used in today's bootcamp, along with the recording of the session. So if you're having any queries, please clarify now. If not, over to you, Pranav.
Yes, Sandhya, thank you. Students, I would like to extend my gratitude for your active involvement in today's session. It was truly a pleasure to have this session with you. Your engagement is greatly appreciated, and I'm excited about the possibility of conducting more sessions in the future. And Pooja, thank you for skillfully facilitating this remarkable session. We eagerly anticipate future opportunities to engage with you all. Thank you, students. Thank you, ma'am.
I'm thanking you again, Pranav sir, for giving this great opportunity for our students to attend this type of data science integrated course. So we like you to conduct many more courses related to this data science, sir. I thank you once again for this wonderful opportunity for our students to attend this data science course, sir.
Sure, ma'am. Thank you, ma'am.
Thank you so much, ma'am.
Thank
Good
you,
day,
Pooja. Thank
everyone.
you, team. Thank you, students.
Thank you all.
Thank you.